rational functions graphs very well. Okay. Example. In this example, we're going to graph a function without using a graphing website or graphing calculator. So you have y equals to 2x squared divided by x squared minus 1. X squared minus 1. In the very first step, when you have a function, you should be finding the domain of that function. Step 1, what is the domain? How do we find the domain of a rational function? The domain of a rational function is r minus the roots of the denominator. Domain is equal to r, all real line numbers minus the set of roots of the denominator. So it is r minus, what are the roots of the denominators? Plus minus 1. We accept every real number except for 1 and negative 1. Why is that? If you plug in 1 and negative 1, you're going to end up with y equals to a number divided by 0. You're going to end up with asymptotes. So in the next step, step B, the second step, find x-intercept and y-intercept. X-intercept and y-intercept. Well, to find x-intercept, we're looking for the values that make the numerator equal to 0. So find the values that make the numerator equal to 0. So by solving the numerator equal to 0, you only have one x value. X is equal to 0. When x is 0, your y is going to be 0. This is your x-intercept. At the origin, the graph hits x-axis. What about y-intercept? To find y-intercept, we set y equal to 0 and solve for x. Set y equal to 0 and find x values. Well, when y is equal to 0, your left-hand side is equal to 0, you have a fraction on the right-hand side. Your fraction is 0 if and only if the numerator is 0. So again, 2x squared is equal to 0. It means that your x is 0. When y is equal to 0, your x is equal to 0. So it means that your x-intercept and y-intercept, both of them happens at the origin. Zero and 0. Okay, after finding x-intercept and y-intercept, we are interested in checking to see if we have an even function or odd function. Step 3. Even or odd. Well, to check to see if you have even or odd function, we need to substitute x by minus x. Substitute x by minus x. So in this case, you get y equals to 2 times minus x squared divided by x squared minus 1. Now, instead of x, we have minus x squared minus 1. Well, if you square negative x, you get x squared back. So you have 2x squared divided by x squared minus 1. We get the function itself. What's the meaning of that? It means that f of negative x is equal to So by negative x, it means that f of minus x is equal to f of x. It means that the function is even function. We have an even function. F of x is equal to f of minus x. Well, here it means that you have a symmetry with respect to y-axis. With respect to y-axis. So so far we know that we have an even function. What else we need? We need to find the vertical and horizontal asymptotes. So in step 4, asymptotes. So to find the vertical asymptotes, we just need to find the zeros of the denominator. Vertical asymptotes set the denominator equal to 0. So x squared minus 1 is equal to 0. It means that x is 1 and x is negative 1. It means that you have two vertical lines, two vertical asymptotes that divide the graph in 3 pieces. Two vertical asymptotes. What about the horizontal asymptote? To find the horizontal asymptote, we need to find the limit of the function as x goes to infinity. Limit of 2x squared divided by x squared minus 1 as x goes to infinity. Remember that since the degree of the numerator and the denominator are the same, the horizontal asymptote is equal to the coefficient, leading coefficient of the numerator divided by the leading coefficient of the denominator. 2 divided by 1 is 2. So y equals to 2 is the horizontal asymptote. Well, in step 5, we're going to use the derivative to find the maximum, minimum, and inflection points. Step 5, find max, mean, and inflection points. Very well. Now let's take the derivative of this function. Remember that to take the derivative, you have to apply the quotient rule. Well, what do we have? We have 2x squared divided by x squared minus 1. The derivative of numerator is 4x times the denominator minus the derivative of the denominator, which is 2x, times the numerator, divided by the denominator squared, x squared minus 1 to the second power. So this guy is equal to, let us distribute 4x, we get 4x cubed minus 4x minus 4x cubed divided by, here we have x squared minus 1 to the second power. We can cancel out 4x cubed and 4x cubed. What's left, guys, is negative 4x divided by a quantity raised to the second power. Well, what does it tell us? It tells us the critical value is x equals to 0, and the rest of them are plus minus 1 that we actually eliminated from the domain. So x, if you set this equal to 0, then x is equal to 0 is the critical value. And if you plug that guy into the original function, you get 0 as the y value. So 0 and 0 is the critical point. So let us take a look at our table. X equal to 0, and then here we can analyze the function itself, the derivative of the function. You can say that, well, here if I plug in, for example, a positive number like 2, what I get, I get 2 times 4 and divided by 4 minus 1, I get a positive value. If I plug a negative number, then I get a positive value. So if I start analyzing the derivative itself, take a look at the derivative. If I plug in 1 into the derivative, I get a negative number. So if I plug in 1, let us write a half, because if I plug in 1, 1 doesn't work here. It makes the denominator 0. So if I plug in a half, I get a negative number. The derivative is negative. It means that the function is decreasing. Then if I plug in, let's write this, oh my God, on this side, a half, then I get negative. The function is decreasing. If I plug in negative a half into the function, then I get a positive number for your positive value for the derivative. It means that the function is start increasing. So at the critical value 0, on the left, the function starts increasing, then starts decreasing. This is the behavior so far. Very well, excellent. We analyzed the functions so far, and these are the information that we have. So let us try to sketch the graph with the information that we have so far. Well, let me erase or just write them down here. I need all of this information. Then I need a little bit of space for the second derivative. So step 1, the domain is R minus plus minus 1. And step 2, define the x-intercept, which is x equal to 0, y-intercept, y equal to 0. At each of these, you get the same value. So it is 0 and 0. In step 3, the function is even. We already know that. Step 3, f of x is equal to f of minus x. We have an even function. It means that we have symmetry with respect to the vertical axis. Then we found the vertical asymptotes in step 4. Vertical asymptotes happen as x equals to 1 and x equals to -1. These two are vertical lines. And then we found the horizontal asymptote, which is y equals to 2. Horizontal asymptote, y equals to 2. Then for maximum and minimum of the function, let me copy this down here. Step 5. The derivative max minimum. Max min inflection. Well, the derivative of the function is equal to here y prime is equal to -4x divided by x squared minus 1 to the second power. And we saw that at x equal to 0, which is our critical value, this is the behavior of the derivative going up and going down. Going up, then going down. Like if you plug in x equals to -1/2, x equals to 1/2, this is the behavior. The function goes up, then goes down. What about the inflection point? So to understand the inflection point, we need to take the second derivative of the function. Well, we can graph it somehow with the information that were given to us. Vertical asymptotes. So for vertical asymptotes, you have x equals to 1, x equals to -1, and x equals to 1. These two are your vertical asymptotes, dividing the graph into 3 pieces. And you already know that at x equal to 0, y equal to 0, you have the intercept. And at the same time, you know the graph goes up goes down, so some part of it left behaves like this. Goes up and goes down. Now we have to analyze the rest of the function. And your horizontal asymptote happens at y equals to 2. Let's use a different color for y equals to 2. This is your horizontal asymptote. Very well. So the second derivative of this function. The second derivative of this function, again, you have a quotient function. It means that you have to apply the quotient rule. The derivative of the numerator is -4 times x squared minus 1 to the second power minus the numerator times the derivative of the denominator. So this is 0.5. The derivative of the denominator is 2 times x squared minus 1 times 2x, the whole thing divided by x squared minus 1 to the 4th power. Before distributing these, try to get rid of the common factor. The common factor here is x squared minus 1 and x squared minus 1, but it has exponent 2. So if you simplify this guy, your second derivative becomes -4 times x squared minus 1 minus 4x times 2 times 2x. And since we took one of these factors, the exponent becomes 3. Exponent becomes 3. X squared minus 1 to the 3rd power. Well, now let us write this in expanded form. We get -4 times x squared, so -4x squared plus 4, and here you have plus, and here you get 16x squared divided by x squared minus 1 to the 3rd power. This is equal to 12x squared plus 4 divided by x squared minus 1 to the 3rd power. If you set this equal to 0, you get x squared equals to negative numbers. If set 12x squared plus 4 equal to 0, then x has no real solution. So what we can do, we can say that, hey, the sign of this fraction only depends on the, actually not even the denominator, because whatever you plug in here, it's going to be positive, and here you have positive. If it's positive, going to be positive. If it's negative, again, you're going to be positive. What you can say that, hey, the second derivative doesn't give me any information that I can use to analyze this function. Well, what's left? What's left? What we can do with this function here, this rational expression, rational function that we have? Well, let's see, can we analyze this further? On the numerator, everything is positive. What about the denominator? Let's think about the denominator. So take a look at your denominator. This guy is always positive. What about your denominator? If you think about x squared minus 1 to the 3rd, the behavior is like this. At -1, so I'm talking about x squared minus 1, and here eventually you can add 3, so 1 and -1. If I plug in any number between 1 and -1, like 0, the outcome is negative. If I plug in anything larger than 1, less than -1, it's going to give me positive. What's the meaning of that? It means that this fraction, the whole fraction, depends only on the denominator. So what's the meaning of that? It means that the concavity is up, and the concavity is down. Between -1 and 1, the concavity of the function is down, the function concave down, and before -1 and after 1, the function concave up. Concave up. Wow, okay, I'm getting somewhere. Another thing that you can do, you can set your 2 equals to the y value of the function and try to see if you can find an answer for it. It means that can you find an intersection between your horizontal asymptote or the function itself? So what you can do, you can set this equal to each other. 2 equals to 2x squared over x squared minus 1. So you get 2x squared minus 2 equals to 2x squared, but it doesn't give me any information, any solution. It means that the graph itself has no intersection with y equals to 2. Graph has no intersection with y equals to 2. It means that it is above your horizontal asymptote. So it means that since we already know that it concave up, it doesn't touch the vertical asymptote. Also, here it doesn't touch your vertical asymptote and neither the horizontal asymptote. So this is the graph.